Hi, kids. A boy is pulling. We're going to do a component problem here, by the way. A boy pulls up on an angle of 20 degrees with horizontal, with a force of 10 newtons on a 7 kilogram wagon. If there's some friction and the wagon starts from rest, we're going to figure out how long does it take the wagon to move 15 meters, and then what is the normal force going to be. So, all right, what do we do first? Well, we always do the same thing first. We draw a picture of what's going on. So here is our boy pulling on his wagon. Okay, and I know that's a beautiful picture. And it starts from rest, and then we have to figure out, like, how long is it going to take to go, when it goes from here to here. If this is 15 meters, we want to figure out the time that it takes. Okay. All right, well, hopefully you're smart enough to realize, that seems like kinematics. Okay, if I'm doing kinematics, I'm going to go A to B. Okay, well, if I write down my givens from A to B, I would say, well, my initial velocity is 0. The distance is going to be 15 meters. I'm looking for the time. Okay, well, I need another variable. Well, I don't know. I'm not going to know my final velocity, but I could find the acceleration. So how do I find the acceleration? Well, I have to draw an FBD, write my, FNet equation, and solve. So let's draw your FBD. So what is the thing that we are worried about? What are the forces acting on? So whenever you're drawing your FBD, it's always, what are the forces acting on? In this case, what are the forces acting on? They're acting on the wagon. So I'm going to draw, here's the ground, here is my boxy wagon. So again, if you'd rather draw just a dot, that's fine. But I think in this case, it makes sense to draw a box. And I'm going to draw forces acting on my wagon. So I have the applied force from the boy. Okay. Now, just keep in mind that that is 20 degrees. Okay. And then I'm going to have the normal force. I'm going to have friction. And then I am going to have the force of gravity. Now, I would like you to pause the video and just make sure it makes sense to you. Why did I make the force of gravity bigger? In fact, if I was doing this correctly, the force of gravity should be equal to this plus something else. So hopefully you can figure that out. So pause the video and see if you can figure it out. Did you pause it? Did you? All right, well, to answer that question, if you take a look, so I have this force, this force, this force, and then this force. And you might go, oh, one of these forces is not like the other. Which one is not like the other? My applied force is. Because this force is straight up, this is, straight down, this is straight to the left, this is up at an angle. So what do I have to do? I have to do vectors and break it into its components. So let's do that, okay? I'm going to break this into its components. Now this should be a right angle, okay? I am going to call this FA parallel. Why parallel? Because it's parallel to the surface. And I am going to call this FA perpendicular. Why perpendicular? Because it's perpendicular to the surface. Then, now hopefully you'd realize and go, oh, well, my FG in this case is this plus this, okay? So now I would hope your next step you'd go, well, I got to write my equation. But you can't just do this plus this, like I can't add that. So you have to write two separate equations. You have to write one for the forces this way and one for all the forces this way, okay? So that's what we're going to do. We're going to write a parallel equation and a perpendicular equation. So let's do that. So let's say I want to write I'm going to add up all my forces that are perpendicular first. So let's do that. Well, what force are perpendicular? Is this one? No. Is this one? Yes. Is this FA? No. Is this FA parallel? No. Is this one? Yes. Is this one? Yes. So now I have to write my equation with this, and this. So how do I do that? Well, which ones are going the same way? This and this. So I would say this plus this minus this, or I would say this minus the quantity, this plus this. Okay, it doesn't matter. Why? Because perpendicularly, my forces are going to cancel out. Okay, and why is that? Well, my wagon is not going to accelerate into the ground or somehow magically accelerate off the ground. It's going to be accelerating left or right. So this has to add up to be 0. So it doesn't really matter if you go this minus these two together or these two minus this. Okay, I'll just say this plus this minus that. Okay, so Fn plus Fa perpendicular minus Fg, and that has to be equal to 0. Make sure that you actually understand why that is again. So, like, again, remember, this thing is accelerating along the surface, not up or down. Okay, so that in this case, in this particular case, this is 0 because it's not accelerating into there. Okay, so there's one of our equations, and then our other equation I'll write over here just because I'm going to have to fill in some stuff at the bottom here. This would be all the forces parallel. Sometimes we'll write it this way, both the same difference. Okay. But what forces are parallel? Well, this one and this one are parallel. Okay. Well, which one is bigger? This one. Which way is it going to accelerate? To the right. So if I write my equation, it has to be FA parallel minus FF. Now, by the way, these forces depended on this picture. If I had my boy pulling it this way, well, then it would be accelerating to the left. So you got to draw your picture. Okay. And then this is going to equal MA. Okay. Now, if you want, you could say this is MA parallel, which is fine. But really, if you want to just write MA, that's fine too. Just like up here, you could write MA perpendicular, where it's not accelerating perpendicular. This is similar to, if you remember, our projectile problems, where the x acceleration was 0, the y acceleration was 9.8 meters per second squared down. Similar to that. But just make sure, again, have it make sense. Don't memorize things. Okay, so first step, and then your second step, and then it's just a matter of you got to plug stuff in. So let's do that. Let's plug stuff in now. So if this, I'm going to redraw it. So we said that is 10 newtons, and this is 20 degrees. So you got to use your mad trig powers. So get out your lovely calculator and use your mad trig powers. So if I say 10 sine of 20, I get 3.42 newtons. If I do 10 cosine of 20, I get 9.4 newtons. So now if I want to plug my stuff in, so let's do this one, because I do have to find the normal force. So if I do this one, then I would say Fn plus 3.42 minus 7 times 9.8 equals 0. And then I can solve for my normal force. So let's do that. 7 times 9.8 minus 3.42. And I get 65.18 newtons, and it is pointing up. Okay, so that was this part of the problem. Hey, what's the normal force? If I want to plug this stuff in, I get 9.4 minus 3 newtons, because that was the force of friction. Okay, minus 3 equals 7 times A. So if I solve for A, 6.4 divided by 7, and I get 0.91 meters per second squared. So then, if I go back to this problem, well, now I know my acceleration is 0.91 meters per second squared, and I have to pick an equation that has all that stuff in it. Well, that would be D equals VOT plus 1/2 AT squared, where this goes away, and then this is 15, 1/2 0.91 t squared, and I could solve for t. 15 divided by answer squared divided by 0.5. Oh, no, I screwed that up. All right, let's try that again. 15 divided by 0.5 divided by 0.91, and then I take the square root of that answer, and I get 5.74 seconds. Okay, and then I have my answer. Okay, but just keep in mind here that again, have your picture lead everything. In this case, we had to write two equations. Why? Because we had perpendicular stuff, we had parallel stuff. All right, goodbye, kids.